Thank you very
much. So you may continue with your session and you can share your screens. Absolutely great. You can make.
much. Is it visible?
Is it yeah, it's visible. Please make it on a full screen. Okay, now this is fine.
Okay. Just.
So you can start now, please.
Thank you very much, and assalamu alaikum all, and very good afternoon. It's a very tricky time because I am stopping you people to go for lunch or to do some refreshments because it has been a hectic day for you people. You have started at 10 and it was already 3 hours of information being shared on regular basis or continuously, I would say. So I would be talking about a different thing. You have been talking about aerosols, you have been talking about air quality, AQI, and then also you have been talking about different models and then monitoring systems, etc. So I will be having some little bit different kind of presentation and just digging further into what we have within the air we have actually and how this air impacts us actually, particularly human health or how human body is impacted by the presence of different pollutants which are present in the air actually. So I will be talking about specifically health impacts, and this is the sequence I will be following for this presentation. And I will introduce you people how it's important to talk about these health impacts of the air pollutants in the air. And I will be sharing a case study that we have done actually here at our institute that is assessing genotoxic effects of airborne heavy metals, particularly in traffic police wardens. And because they are the personals most of the time exposed to this air pollution actually. Then a few concluding remarks and the acknowledgements from the to the funding agencies and the people around actually. Please have a look on this graph, and I will be coming back as well from the next slide just to highlight the importance actually how it is important to consider these risks. This gives you an idea about global ranking of risk factors by total deaths from all causes in 2019. And air pollution is at 4th and significantly causing or being the cause of death of 6.67 million people. And here, one thing that I don't really wanted to highlight, but it most of the time it comes in front of us, and that's malnutrition also. So here you see in the developed world, malnutrition is on the lower side. But if you look on the Pakistani picture, just I switch to pointer option. So here you see the, I'm not sure what is, sorry, there is some thing. No. Okay. Ali, if you can remove this sign, I'm not sure why it came here, but if it's possible for you, please remove it. Okay, I move ahead. So here, in with respect, particularly if we talk about Pakistan, and here you have the number of leading risk factors for death and disability, and dietary risks, they are on the top. Then air pollution is on 6th number. And again, it's very important that this being at even 6th number, the number of deaths, they are very high. And if you go further into the details of the different components of this air, you may have contribution from ambient PM 2.2, then hazardous air pollutants, and then ambient ozone. You have talked about good and bad ozone, so I'm not going into the details. So that is, I hope you people have already understood. But if we dig further into these 128,000 deaths, which are mainly due to air pollution, and that happened in 2016. Further, it may have some, you may not have this 100% of the total of these, but there may be some overlapping. So please don't calculate that it doesn't make 100%, but yes, there is some overlapping. For example, here you can have obstructive pulmonary disease deaths, about 47%. So mainly due to air pollution. Then diabetic patients, they may have some contributions from this ultimately. And then heart diseases, they are also linked with air pollution. Lung cancer also contributes a significant number of deaths within this. And then stroke deaths, they are also contributing about 14%. So ultimately, once you are exposed to this air pollution or different pollutants in the air, actually, you are under stress, and ultimately there are chances that one or the two or multiple factors can influence and can lead to certain disease or certain impact, and that may not be irreversible. Okay, so once we have this poor air quality, as you have been talking about different pollutants and criteria pollutants, ultimately, who is being affected by this poor air quality? It's the common people. We can talk about in detail that we have these sources, industrial sources, vehicular exhaust, vehicular emissions, then also type of the pollutants, polyaromatic hydrocarbons, heavy metals, SOx, NOx, CO2, ozone, greenhouse gases, and then you have recently seen the list of pollutants presented by Dr. Fahim as well. And ultimately, who are the victims? They are primarily occupational groups, mainly traffic police wardens who remain most of the time on the road. Then professional drivers, because their activity forces them to be on the road, and general public, once we travel or once we get out of our home, then definitely we are exposed to this air pollution, or even if air quality is not good at home, that may also influence your health as well. Okay, so specifically talking about these heavy metals which are present in the air, here is the data. It's a little bit old data, but it gives an indication that there is a significant amount of different pollutants, particularly different metals, that is entering into the atmosphere, or that's entering into the air. So here you see up to 8,000 tons, 8,400 tons of cadmium being deposited to lands throughout the world through atmospheric deposition. Then here you see different metals, zinc, lead, copper, cadmium, and nickel. They also contribute about 90% of all heavy metals emitted by vehicular exhaust. Although we can say that we use lead-free petrol or gasoline right now, but still there are so many other usages. They are also contributing. For example, we have it's a lead battery industry, which is booming because we have been using UPS systems, etc. And ultimately, we are having these this metal actually in all the homes, almost in all the homes within Pakistan. Then zinc is also being released from tire wears, about 10,000 to 11,000 tons for the year 1999. So it is, again, I said it is a bit old data, but it gives an indication that zinc is being mainly contributed to the air from tire wears, and we can't avoid these tire wears, and we only need to change that. We reduce the contribution of zinc metal in the tire wears. Here to give just an idea of how the local situation is within, here you see different cities from Pakistan, the Islamabad, Gujranwala, Faisalabad, and Bahawalnagar. And here is the concentration of different metals, concentration nanogram per meter cube. And you see in both the industrial cities, Gujranwala and Faisalabad, concentrations of the metals, they are, although they're just a couple of metals, so their concentration is quite high. And it's, I would say it's alarming, so that is beyond the WHO limits. So we need to consider that we protect ourselves, or we at least we reduce the emission of these metals to the air at source. Okay, so just to recap, what are these the sources of cadmium and zinc, particularly into the air? There's cadmium. It can smoking is one of the contributor, and then nickel cadmium batteries. They are also one of the major contributors towards cadmium concentration in the environment. Then for zinc, tire dust is the main contributor. Then bake dust also contributes some amount of zinc. So overall, we have both cadmium and zinc in the air, and that can lead some negative impacts on human health. So here you see some of those health impacts I'm talking about. It may have genotoxic impacts. We need to understand what is genotoxicity. Genotoxicity is primarily it's the early damage to DNA. If the exposure is removed, then there is a possibility that it can recover. But if there is a constant exposure, it may lead to mutation and finally to carcinogenicity. And these genotoxic effects can lead to unscheduled DNA sequencing within the cells. Then DNA strand breaks. I will show in the upcoming slide how these DNA breaks happen actually. Then human disorders that can happen due to these heavy metals. There's cancer, renal failure, permanent respiratory, and cardiovascular diseases. Then ecological damage that can happen. Actually, these metals can enter into the food chain, and they may influence us directly or indirectly, either through food chain, either through our respiratory intake or through food intake. So ultimately affecting both animals and plants, and also damaging our ecosystem in a way that it's not healthy for us. Okay, so other than heavy metals, here you people see just to give you a glimpse of what we have in our air in Pakistan. This is data from one of the students who worked in Faisalabad. And here you see the different pollutants, polyaromatic hydrocarbons. Here we have the concentration on y-axis, and you see very high concentration of naphthalene recorded, particularly in PM10. That was the samples that were collected from Faisalabad. So why it's important, or what the message it gives actually, we have both type of pollutants, that's metals and organic pollutants, inorganic and organic pollutants. Both they are present in the air, and they are affecting negatively a human being as well as the ecosystems. Okay, so coming to the case study, I was talking about the assessing genotoxic effects of airborne heavy metals, and we mainly focused on cadmium and zinc. We analyzed only these two. Lead is also one of the very important pollutant. Some of you might ask that why we didn't consider it. So due to certain limitations at that time, but now we are able to consider that as well. And definitely lead is one of the significant pollutant affecting human health in current scenarios as well. Okay, so what is genotoxicity? I just defined earlier, but we measured this genotoxicity through Comet assay. That is one of the techniques used in toxicology, and particularly in pharmacy as well, or pharmacological studies, and also in health-related studies. But what is genotoxicity? How it happens? Once the DNA is exposed to a pollutant, it can lead to strand break. So here you see this strand break due to the environmental pollutant. If this pollutant is removed, or exposure is removed, there is a possibility that this DNA will repair itself and we will have the normal strand. This is one possibility. There is another possibility that this growing recombinant 4 continues, and this division or duplication of the DNA continues, and it reaches to the point where there was the strand break. And once this reaches here, this will separate from other two strands, which we have duplicating or replicating strands. So replication 4 collides with the single strand break, resulting in double strand break. So here, what we gained actually, instead of having 2 strands, we have 3 strands, 3 different strands, and that is the breakdown. And ultimately, this breakdown can lead to cell death. And if there is a cell death, ultimately, it can be problematic for the organism in which this is happening. So to do these genotoxicity assays, and we used Comet assay, and also we measured the metals in the blood samples. We started with the sampling of control group. We tried to have those people who don't have exposure, particularly a habit of going through the roads, or not the drivers, or any person which is living near the roads. Then the other group was traffic police wardens. We collected samples from Rawalpindi, and this sample, the blood was further processed for analysis. And in analysis, what we did heavy metal analysis. What is the concentration of the heavy metals in the blood? Then hematological test, for example, what is the level of platelet count, and then what is WBC, then red blood cells, or particularly hemoglobin. And then we also process these cells, or this blood actually, for genotoxicity assessment. Okay, so here, what you see actually, we can have 2 types of results. This is the normal cell. We may have round cell, but if it's damaged, there is a possibility of formation of a comet or tail. That's why this test is also termed as Comet assay. So we may have a breakdown of DNA material, and we may have, depending upon the concentration or depending upon the level of the pollutant or concentration of the pollutant, we may have longer tail or smaller tail. If lower level concentration is being exposed, we may have smaller tail, and if the concentration is higher, then there is a chance that we will have longer tail or more damage to the DNA. For heavy metal analysis, we use flame atomic absorption spectrophotometer or spectrometer. That is a traditional technique which is available in most of the labs. And for sample preparation, we can do acid digestion and then do the routine processes for determination. So this here is the result of what we did actually in terms of cadmium and zinc concentration in the blood samples. So here is the here are the mean values, and then here is the range, and then for the this is for the control, and this is for the exposed. So just have a look on the data. Actually, it is alarming. For me, it's alarming because WHO limit is 0.0012 milligram per liter. It is almost 15 times more here in the traffic police wardens. Similarly, here it's a 3 milligram per liter zinc concentration. That is acceptable limit, permissible limit in the blood. It's 1.5 times more zinc.
Excuse me, Doctor. Sorry to interrupt you. Your slides are stuck actually. We are still at sampling process.
Is it okay now?
डॉक्टर साहब, अगर आप स्क्रीन जो है वो स्टॉप शेयरिंग कर दें एंड दोबारा स्क्रीन स्टार्ट शेयरिंग कर दें, प्रॉब्ली इट विल वर्क.
Is it okay now?
Is it? Yeah, it's okay. Now let's make it on a full screen.
Okay.
Okay. Yeah, we are back.
It's okay now? Okay, thank you. Sorry for the interruption. And here you see what I was talking about, that the concentrations which were determined actually, which were found actually in the traffic police wardens' blood, they were very high as compared to the limits available as per WHO, and they were almost in case of cadmium 15 times higher, and in case of zinc it was 1.3 times higher. And here you see the hematological parameters, where on the y-axis we have white blood cells values, and then here we have the control group, and this is the I would say kind of exposed group, that is traffic police wardens. What is important here that WBCs are lymphocytes. They are mainly higher in number when there is an infection. So what it shows, or what we can interpret from it, actually, once there is accumulation of heavy metals in the blood, it gives the similar response that we have from, for example, microbial infection or any other infection happening to the body. And overall, these levels are relatively higher in traffic police wardens as compared to the control group. In case of platelet count and hemoglobin, although we can say that these limits are within the acceptable limits, or within the acceptable ranges which are available, are globally accepted, but this difference between control group and traffic police warden indicate that there might be higher need of oxygen, or oxygen requirement might be increased when there is a exposure to these heavy metals. And to fulfill that oxygen requirement, or to reduce the toxicity, or to combat with the negative impact of the heavy metal, there is a possibility of production of more red blood cells, and ultimately having higher hemoglobin in the blood samples of traffic police wardens. Okay, and now talking about genotoxicity and what were the levels of DNA damage here, we see the damage frequency. It's the overall calculated as number of cells, damaged cells, divided by overall number of cells counted or considered actually. So here you see, in case of young people, although impact was lower, but if you compare the control and traffic police warden, there is a big difference. It's about 30% or 28% of the cells were damaged in case of traffic police wardens. And with, you can say, increasing age, the impact is further, I would say, strengthened or is higher actually, and over 40% of the damage frequency was observed. Okay, so again, there is some problem, but I hope it's visible. In case of tail length is representative of how much damage has happened to that specific cell. If there is a higher concentration, we will have more tail length. And if there is a less concentration of the metal, probably or less toxicity, that means the tail length will be less. So here you see that again, age-wise, young people may have ability to recover well, or recover easily, or to you can say repair damaged cells quickly. But with increasing age, there is a possibility that we may not have that kind of tendency, and overall tail length increase. But remember that there is also possibility of having some background damages as well, and I will show in upcoming slide what is that actually. Even if there's no concentration of certain metals, few of the samples actually, they may have some DNA damage as well, and that could be due to certain other reasons or certain other stresses, or maybe due to certain other pollutants as well. So here is the tail length versus cadmium concentration. On x-axis we have different levels of cadmium that were detected in the blood samples, and then tail length. So as the concentration increased, there is also increase in tail length. But one thing that is important, that was I was talking about background damage, and there are certain individuals where we couldn't detect cadmium, but still there was DNA damage, and this can be attributed to different other stresses that may not be specifically due to cadmium or zinc, that may be due to any other metal or any other organic pollutant as well, or even some disease as well that may not be that might not have been noted in the questionnaire as well. Again, here we have the concentration of zinc on x-axis and the respective tail lengths. And what is the outcome? That as the concentration increased in the blood samples, there was also increase in tail length. And again, few of the samples having almost a zero zinc concentration, but still having some tail length, that indicates it could be due, it can be attributed to certain other pollutants as well. Okay, so with that, I conclude that air pollution has some critical impacts on human health, and particularly from this study, we can conclude that cadmium and zinc concentration in traffic police wardens cross the permissible limits suggested by WHO, and there is link between concentration of heavy metals and DNA damage in traffic police wardens. And the technique we used, that is Comet assay, an effective tool for genotoxic assessment as compared to the hematological parameters, where the impacts were not very significant as compared to the Comet assay studies. So just to conclude, final remark is that we need attention, particularly with respect to the protection of all those personals, all those occupational groups working in those domains where the exposure is high. There is need for having protective gears, and there is also need for working on particularly improving the air quality, so that all these people live in a healthy environment and protect themselves from the damages. Okay, so finally, I would like to acknowledge the financial support and technical support and facilities from NUST, from Higher Education Commission of Pakistan, City Traffic Police, Rawalpindi for cooperating for sampling purposes, PIMS Hospital, Islamabad for some analysis, and then my team, that's Environmental Biotechnology Research Group. Last but not the least, Professional Development Center of NUST for providing me this opportunity to share my work with you people. So thank you very much with this. If there is any question, please do ask.
Thank you, Dr. Saab, being very well in time and sharing with us such a very interesting topic. So now the forum is open for quick question and answer. One request to the audience, please try to be very precise and to the point while you're asking the question, that just to avoid the wastage of time. Please, Mr. Iftikhar, please go ahead.
Thank you, Dr. Rashid, for sharing actually such an alarming data. My first question, actually I have two questions. My first question is about one of the slides you shared about the Faisalabad's data, where you were mentioning about naphthalene. And actually it was the evening time where the concentration of naphthalene was very high. I was wondering why. And my second question is about the data you shared about that case study. I'm assuming that it was a cross-sectional study, not a time series study. So I was wondering, number one, would the results have been different if it were to be a cross-sectional study? And number two, was the comparison with the control group, which did not have any person working in the same environment as were the wardens? So could we have a different control group? For example, the wardens working in a relatively better environment and the wardens who were exposed to the higher levels? Thank you.
Okay, thank you very much. Yes, first of all, the data related to Faisalabad is a specific time, particularly if we talk about afternoon or evening time, where you might have congestion and you might have very high levels of the contaminants. So that's one thing, but it was just kind of indication. I didn't present in detail because there are detailed results as well. So that was just to highlight the problem exists actually. That's one thing. So not going into the details whether it's a cross-sectional. Yes, it was a one-time study. It wasn't like time series as well. Secondly, talking about the traffic wardens. Yes, again, I would say it is not time series studies, but the individuals selected are the sampling that was over. I would say it would have been ideal if the sampling were over the years, for example, 3-4 years, that would have been ideal, but we did sampling within 1 month. So that may impact overall the conclusions, but it just give an indication that there is need to dig further into all the details, and the situation is critical, and we need to further focus on it. And then talking about the controls, unfortunately, right now we don't have any pristine environment in the world, actually, keeping in view the scenarios and keeping in view the ability of air carrying all the pollutants from one place to another. So it is really difficult to have the pristine environment where we find perfect controls who are not exposed to any kind of pollutant. So this is one of the problem that was with us, actually, while considering those controls. But we tried to the certain levels that all those peoples who are exposed to the, particularly to the air pollution, their exposure was minimal, actually. So that was one thing. Yes, if you have any other idea, we would be happy to listen to you. But yes, we also consider, for example, we go to a village and get some samples from there, and might be those people having less exposure, but still there is a chance that they are exposed to any other pollutant, for example, burning of fuels or wood fuels. Actually, that is something the common practice in villages. So they may also be exposed to certain smoke related things. So that may interfere with the results, actually. So the point is valid, but yes, there are limitations as well for the study.
Yeah, just to add on this, yes, we can actually go for a variety of control. We could be very precise about clean mode. So I mean, we can have like a city with pristine, relatively pristine atmosphere. We can select control group from there as well. We can compare, but within that city, we can go for both. And comparative study with the polluted and relatively clean study, we can go for that. But as Dr. mentioned, that there should be other factors like biomass burning, like wood stoves and all these things. That matters a lot. The setup, residential setup, exposure of people, even of the control in both the traffic wardens. But because I would say this was quite good and interesting, because these are actually the working group which are very much exposed to the pollution level, which are at the immediate exposure to those. So I guess you can extend work to several extents, depending on resources and availability of funds. Any other question from the audience, please?
Yeah, Dr. Fahim, I'm sorry if there is no other question, and if I can get a minute, just a minute, please.
Yes, please go ahead.
Yes.
Sure. Actually, I wanted to make a short comment, because the thing is, I was worried about neurotoxicity, the interaction of genotoxicity, and could it be affected by neurotoxicity, because under certain stresses, under certain environments, there are certain neurotoxins which are being emitted, and sometimes they also weaken our immunity. And even if we are comparing, for example, a person working for 8 hours straight, for example, I'm an academician, you are an academician, sometimes we have to sit for more than 12 or 14 hours. We might not face the same stress as the wardens do, but we also are working for the similar long straight hours, but we are not going through, alhamdulillah, going through those genotoxic effects. So that was my point, that control group, it might not be a person who is exposed to a lesser harsh environment or more harsh environment, but working, maybe the effect of stress could be more prominent in this case.
No, this is true. Actually, this is actually on this slide. If it's visible to you people, I highlighted that even we couldn't find the concentration of the metals. Even there's no exposure, but still we find the genotoxicity. So what is exactly reflecting what you are saying? Actually, we may have some neurotoxicity or other stresses. They may also lead to the data shows or literature shows there is a possibility that due to these other kind of stresses, you may have some DNA damage as well, or cell damage or genotoxicity. But to single out what is the exact reason, it would be requiring holistic studies, long-term studies, and then going into or having those type of all individuals, which is particularly working with human. In Pakistan, the scenario is really difficult. So having human subjects as samples, that's again very critical, and handling and processing of the samples, and then having those set of, you can say, the protective measures you have to take. So it's, yes, point is valid, and definitely it reflects here as well. And then definitely we can go for certain specific statistical models or chemometrics, and we are on it. Actually, one of colleagues is working on it, and let's hope that we come up with certain new findings in near future as well. Thank you.
Yeah. Okay. So on a lighter note, Dr. So if there is no other further question, I just curious to know about this outlier, which is 0 with zinc and 0 with tail length. I want to really keep this healthy person.
No, actually, that's what I said. Actually, even in the absence of these metals, there is a possibility, because we couldn't do all the metals. It would have been nice if there was also data of nickel, cadmium, or other metals, and combined data of those metals, and then also the polyaromatic hydrocarbons. That would have been interesting to know whether those combined impact is also contributing, and then some stresses as well that they may also contribute. So this is the circle, this is the area that needs to be explored, and that's what I said, that's a black box we need to dig into.
I hope it wasn't from ISE.
No.
Thank you again, Dr. Saab, and for asking, putting questions. Very interesting one. So, Ali, I guess we move to. Shall we have a break? So I will take credit this time. The audience want to break?
Gee, I think so, sir. Everyone would be agreed to that.
No, I agree actually. This time I want to own credit for this break.
Right. Sure,
But
sir.
thumbs up, otherwise I could have gone for the break.
Gee. So let's take 5 minutes break, sir.
Okay.
The credit
Okay.
goes to Dr. Fahim. So let's come back at 3:47.
Okay, appreciate it. Thank you.